We spent the last 10 months designing and building this electrically paced cardiomyocyte bioreactor that we like to call the epc.REACT. Currently, one of the biggest challenges in the field of cardiac tissue engineering is culturing tissues with physiological hallmarks such as intercalated discs and sarcomeric banding. This bioreactor uses electrical stimulation and an improved tissue mold to allow the user to culture 3D cardiac microtissues. The bioreactor consists of three main parts, which were designed and 3D printed with biocompatible and non-cytotoxic materials to achieve the requirements of making a small, compact, and functional system. In between the top and bottom 3D printed pieces is a glass cover slip sandwiched between two custom-cut silicone gaskets, making the system watertight. The tissue mold is made of PDMS and is plasma treated to the cover slip to hold it in place in the bioreactor. Flanking the sides of the tissue mold are carbon electrodes that provide electrical stimulation for the cells, controlled by an Arduino, the code for which can be updated wirelessly at the user's convenience. A 3D printed lid with a clear glass window fits over top of the bioreactor, which is assembled using stainless steel hex bolts and nuts. The entire system is safe to be sterilized in an autoclave, either as a whole or as individual components. It was very important to us that the bioreactor be low cost to produce and that all the parts be modular so that they can be easily replaced. With the potential ability to culture enhanced three-dimensional cardiac tissue, this device could be used in early-stage drug trials to see how a drug affects the tissue's structure and electrical function. Testing new drugs with the device could decrease potential harm that animals would face in early testing. Here's a video that we put together highlighting the features of the epc.REACT.
Welcome to a brand new, budget-friendly, electrically paced cardiomyocyte bioreactor, or as we like to call it, the epc.REACT. Built with a modular frame, this bioreactor is composed of 3D printed parts and simple materials. The epc.REACT's walls are armed with electrodes for stimulation. Housed inside the culture vessel is a customizable PDMS mold for microtissue culture. An Arduino interface allows the frequency and duration of the electrical pulses to be updated wirelessly at your convenience. epc.REACT is a new platform that can continually be modulated to improve its ability to culture stem cell-derived cardiac tissue.